This is section 6 of the paper 2 revision for hire. Here we've got a question all about inequalities, but the difference with this one is that it wants us to show regions of inequality. Whilst the question on the mock might be a little bit trickier than this one, we can quite easily get at least a couple of the marks by doing some of the basics. These can be shown in this question here. If we imagine we had a set of axes drawn on the paper in front of us, with this being your x and your y axis, where it says here that it wants us to show the regions defined by -3 less than or equal to x less than or equal to 6, what we would need to do is show that all the parts of this graph where x is between these two values. So with this being our x-axis, I would need to put a little mark at -3 and 1 at 6. Now for all the values where x equals -3, we could therefore put a vertical line going through -3, and for all the points that are equal to 6, we could put again a vertical line going through 6. Now every area within this section here, every bit, satisfies this inequality. So it's between -3 and 6. For this one, the y coordinates between -4 and 5. So again, if I put a little mark at -4 and another one up at 5, we would need, because it says less than or equal to 5, we would need a horizontal line this time going through 5, and then with a slight difference, because on this one y is greater than -4 but not equal, we would do a dotted line going through -4. So the area that satisfies these two inequalities is everything within this rectangle. So the x values are between -3 and 6 within here, and the y coordinate values are bigger than -4 and up to 5. Where it says for part B about whether the following points are in the region, all we need to do is see whether or not these coordinates are actually inside this little rectangle. Coordinate 2, 2, so we've got along to 2, up to 2. We know it's roughly about there because obviously 6 is here on the x-axis, 5 is here, so this would be 2, 2. So yes, that coordinate is within the rectangle. The coordinate 1, 5, where we go along 1 and up 5, that was give us a point here that's actually on this line. Because this is a full line, and we said that y could be 5, we would say yes, this one is satisfied by the inequality. For the final one, -2, -4, we would go along to -2, down to -4. Now this would put us here. Whilst it does, like the one up here, appear on the line, because this dashed line means that everything is bigger than -4 but not equal to it, we would say that this point is not satisfied by the inequality. Next topic we are looking at is functions. We did this a little bit earlier this year. Here we've got the function f of x, so this is 2 to the power of 3x, and g of x is x to the power of 4. A little bit scruffily written, but those are the two values. When it says work out the values for these two questions here, all we do is substitute the number in the brackets for where the x is in the two expressions. So for f to the power of 2, all we would need to do is 2 to the power of 3x, so 3 times 2, so 2 to the power of 6. So the 2 there replaces that x, 3x becomes 6. Plus g to the power of 3, so I'm going to replace the letter x in g with the number 3. So x to the power 4 becomes 3 to the power 4. If you use a calculator to work these out, 2 to the power of 6 is 64. 3 to the power of 4 is 81. So add the two together, gives us an answer of 145. We do the same for the next one. F of 1 means that we would do 2 to the power of 3 times 1, so 2 to the power of 3, plus G5, to replace this letter X with 5 to give us 5 to the power of 4. Again, using your calculator, 2 to the power of 3 gives us 8, plus 5 to the power of 4 is 625. So if we add these two together, it gives us 633. Now when we get on to inverse functions like this one, g to the minus 1 of 81, this is quite high level. So if this is the element that you're not too happy with, don't worry too much. This is looking at the grade 8 and 9 work now. So g to the minus 1 of 81. If we kind of just ignore the 81 for now, let's just look at the function as an inverse to start off with. So if I were to write g of x equals x to the power of 4, that's the thing we were given up here. To find the inverse, what I do is I try and make here x the new subject of the formula. So here, the opposite of doing something to the power of 4 would be to do the fourth root of it. So this gives us the fourth root of g of x equals x. At that point, when we did this topic a little bit earlier in the year, I then said, just as a little trick, just something that works to make this happen, we then change the g of x into x, and we change the x into g to the minus 1 of x. So what we've got here is the inverse of this function. What the question wanted me to do was to substitute the number 81 into this new function. So what I would do to find g to the minus 1 of x, g to the minus 1 of 81, is I would replace the letter x here with the number 81. Now if you type into your calculator the fourth root of 81, that would come out as 3. As I said, if that's the bit that you're not too happy with, don't worry too much. That is quite complex. It is very high level. The final thing it's asking us to do with functions, is here, g of f of x. What this means is we take whatever f of x is, in this case here, and we substitute all of that into g of x. So what I do here is I'm going to replace this letter x here, so let's write this letter x, I'm going to replace with this. So I would put 2 to the power of 3x, and then I need to do that to the power of 4. So I'm going to pop that into a bracket just to make this a little bit easier, and do that to the power of 4. Now remember, if I do something to the power of 4, that simply means I times it by itself 4 times. So here I would write 2 to the power of 3x times 2 to the power of 3x, and repeat this, so I've got 4 of it. Now when you are timesing numbers together with powers, remember the quick way of working it out would be to do 2 and then add together the powers. So 3x plus 3x plus 3x plus another 3x would give us 12x. And this is the value of g to the f of x, or g of f of x. The next topic is this one. It's all to do with drawing some graphs. Now all the ones we've looked at so far have been y equals 3x plus something, or maybe y equals x squared. Here we've got some where the x is actually part of the power. Now these we haven't done yet, they're in a topic that we're going to do a little bit later in the year, but I can quickly explain some little bits to do with it now quite easily. All I would do is the exact same as I normally do. So if I say x and y, and I'm just going to use the exact same numbers I normally do. Here we can now use a calculator to do it. So when x is 3, that would mean 5 to the power of 3. 5 to the power of 3 is 125. If x is 2, that means 5 squared, so 25. 5 to the power of 1 is just 5. 5 to the power of nothing gives us an answer of 1. If you want to type this into your calculator just to prove, you can do. 5 to the power of minus 1 would give us 1 over 5, or 0.2. Remember, you can do this on a calculator. 5 to the power of minus 2 is 0.08. And 5 to the power of minus 3 gives us an answer of, sorry, my mistake, that one is 0.08, that one is, 0.008, and that one is 0.4. It does just say sketch the graphs, so at that point I would draw a little set of axes looking something like this. Notice the y coordinate does not go into the negatives at any point. At 0 it gives us a value of 1, so that number there is 1. It gets very big very fast, so on this side it goes up very quickly. This side it gets smaller but in slower and slower amounts. So it would look something a bit like this. This is known as an exponential graph. For the other one, the exact same idea. We don't really need to do as many values for this one because we will see the numbers get very big very quickly on this one. So in fact on this I'm going to keep it as minus 1, 0, 1, 2, 3. If you type into your calculator 4 to the power of, and then 3 times minus 1, so this one would be 4 to the power of minus 3, that gives us an answer of 0.01562. Very small, very quick there. This one would be 4 to the power of 3 times nothing, so 4 to the power of nothing, which is 1. Here we would have 4 to the power of 3 times 1, so 3 times 1 is 3. 4 to the power of 3 is 64. Again, I'm just using calculator to do this. For this one, 4 to the power of, if x is 2, we've got 3 times 2 is 6, so 4 to the power of 6. Now if you put that in your calculator, 4096, very large numbers very quickly here. And for 3, same process, that gives us 4 to the power of 9. Now that comes out as 262,144. Same setup, little set of axes, just a sketch, you don't need to do this accurately, but this one, as you can see, very small number at minus 1. It will hit 1 when x is 0, and then these numbers very quickly get big. So it would do something like that. All you need to realise, the bigger the power, the steeper and faster the graph will move up.